Good morning. Today is the first session for DBA Fundamentals virtual chapter. Today we have Erin Stellato doing migrating to In-Memory OLTP. I'm not going to talk a lot about different things. We're going to start off with Erin pretty soon. I just wanted to point out that we have a lot of good sessions out there this first half of the year, and we have a contest running to where if you join our YouTube site, dbafuntube.org, or join PASS, you have to actually be at least in one of these two things, in PASS and a member of our virtual chapter and a member of our YouTube site, to be eligible to win a $1,000 gift card. And we also have, I think it's a $300 and a $200 gift card, because what we're going to do is just going to give away everything that we have for the year all in one shot, or at least for the first half of the year. So I'm going to turn it over to Erin right now with SQL Skills. So take it away, Erin.
Thank you, sir. Hi, everyone. Thank you for joining today for this session on migrating to In-Memory. I work for SQL Skills, so just a little bit about our team. Paul Randall, Kimberly Tripp, they are the owners of the company. And then there's Glenn, myself, Jonathan, and Tim Radney. We provide training through sessions like this online, in person at SQL Saturdays, at Summit, at SQL Intersection, and also through our training events, immersion training events. And we have training online in PLURALSIGHT. We provide consulting, and if you want to hear from us on a regular basis, you can check out our newsletter. That link is there at the bottom. This is the Yay Me slide, and the most important thing on here is really my email address. There's a questions window here in GoToMeeting or webinar, whatever. I'm sorry, I don't even exactly know what it is. But in the software, you have the ability to ask questions today. Feel free to do so. If I don't get to them, I will do my best to follow up, but you can always email me directly if you have questions. This is a little bit about the classes that we have available through SQL Skills. Check out our training page. And if you're interested in services and working with us for consulting, please hit the services page there at the bottom. And we've got SQL Intersection coming up in a lot of great content there. And if you have never checked out PLURALSIGHT, you can email Paul directly, paul@sqlskills.com. And you can put in there DBA fundamentals, user group, PLURALSIGHT code, and he will send a free 30-day trial, a code for a free 30-day trial for PLURALSIGHT if you've never checked it out. So we've got, it's now at this point over 180 hours of content on PLURALSIGHT.
Erin.
So here's the abstract for today.
The sounds going in and out, and I think we've had this with when speakers are a little fast, or if they're changing their screens fast, it kind of affects it a little bit. So if you can slow down just a tad, because I want everybody to hear everything you say.
No problem. That was just the boring stuff anyway. So thank you for that reminder. I do tend to talk a little bit fast because there's a lot I want to say, and I'm really passionate usually about what I'm talking about. So I get really excited, but I'll do my best to slow down. So the abstract, I'm assuming that everyone has already seen, so I'm not going to read through that. But just to make sure that we're on the same page, this is not a dive into how In-Memory works. We're going to talk a little bit about the basics behind it. What I really want to talk about today is if it's a solution for you, and if it is, or if you're not sure, how you test for that. Because a lot of what we see from Microsoft is how great In-Memory OLTP is. And I'm not knocking Microsoft here. Writing software is really hard. Writing software to serve the masses is extremely difficult. And there are some very specific scenarios that this satisfies. And that's what I want you to start to think about today. So we're going to do a little bit of a review of In-Memory. And I already have a question about how much is going to pertain to 2016 versus 2014 versus general structures. I'm going to point out differences between 2016 and 2017 where appropriate. I'm really not hitting things specific to 2014. That was a V1 release, right, when it initially came out. And there are some limitations that obviously have been addressed in 2016 and 2017, but I'm not going to differentiate in every location between all of those. So once we do a little bit of a review, we're going to look to see if it's the right choice for you and how we implement and how we test. So we'll start with that review. So I asked myself, how do you fix performance? And I came up with this whole list of things, and this probably is not even a complete list. You all might come up with some things that aren't even on here, but if there's a performance issue, one of the first things to try to do really is to look at whether it's something that you can address through code or through schema changes. And I know that a lot of you have third-party tools out there, third-party applications and databases, and you don't have the ability. But I know some of you, and Michael, I'm thinking of you specifically, you are developers and you do have the ability to make those kinds of changes. And I would encourage you to start there, right, with code and with schema. And code changes can be optimizing those queries, optimizing transactions, returning the data that users really need. And I mean like really need, right? Not select star, but select the columns that we need and really fine tuning that predicate. And does it need to be ordered specifically? Can you cache that to order it? Client side, looking at how you use functions and cursors and row-based versus set-based operations, maybe changing isolation level, looking at plan cache use, right? All kinds of optimizations in terms of code. And then in terms of schema, maybe you need to normalize, maybe you need to denormalize. Maybe you don't have primary and foreign key constraints defined, or maybe you don't have any other constraints defined, which the optimizer does rely on that information. Maybe people didn't make some great choices in terms of data types, and those need to be addressed. And maybe you need to index. Indexing is a huge, easy win, in my opinion, a great place to start when you're tuning. A lot of the systems that we look at have a lot of indexes that can be added to really improve performance. I have update statistics on here, and then I have an asterisk after it because that's a common thing that people think to do first. I actually had a session this past weekend at SQL Saturday in Cleveland, and I asked about, when you've got a performance issue, where do you start? And somebody answered immediately, you update statistics. You could do that. That to me is a knee-jerk response. I really want to understand why there's an issue before I just go and update stats. Maybe you change to the newer cardinality estimator. Maybe you find you've got TempDB contention and you need more data files. Maybe you have way too much data, right? And even indexing doesn't help you. And so you remove that old data, you archive it off. Some folks tend to think that partitioning is a way to improve performance. And partitioning really isn't designed as a performance benefit. You can get it, but that's really not what we think of when we think of partitioning here at SQL Skills. There are a lot of other reasons that we partition. I would imagine that a lot of you have a OLTP environment that also ends up having reporting against it, and that can really affect performance. So maybe reporting needs to go somewhere else. Maybe you force plans using a plan guide or query store or automatic tuning. Maybe you need to upgrade. Maybe there's a specific bug that you're running into, or maybe there's a new feature that you're taking advantage of. Maybe you upgrade the hardware, adding CPU, adding memory, adding storage. And CPU has that little asterisk there because we don't see linear improvements with CPU, right? Doubling the CPU doesn't mean that you've really improved performance twofold. So it really depends on what your issue is and where you're adding hardware. And one of the last things here is using new features. So do we approach it as a new feature means that we get an immediate win? And if I think about the new features that have been added in the past, 3-4 releases, 2012 on up, we've got column store as an example, we've got delayed durability, we've got in-memory OLTP, buffer pool extension, plan forcing with query store with automatic tuning. So if I implement these, do I for certain get an immediate performance improvement? And you can, but it has to be implemented correctly. So when we talk about in-memory, this was introduced, as I said earlier, in SQL Server 2014 Enterprise Edition. It was enterprise only then. Additional features were added with the 2016 and the 2017 releases, and it is also available in 2016 SP1 and higher standard edition, but there's a limitation of 32 gigs of in-memory objects per database. So you don't have to be on enterprise starting with SP1 and higher, but you do have a limitation in terms of how much space you've got for those in-memory objects. And so where this came from was, even though memory and IO are pretty cheap, memory and CPU are pretty cheap, IO ends up being the limiting factor in most environments. I don't see a ton of systems that are really constrained in terms of CPU or in terms of memory. And typically we see bottlenecks around those disk-based structures, those clustered indexes, those heaps, those non-clustered indexes, related to locking and latching. And writing to the transaction log. And so we get concurrency issues where multiple users are trying to access the same data and somebody has to wait. And we get latency issues. And so in addition to looking at what data has to be retrieved from disk, there's also the fact that running that code, those queries, those stored procedures, requires a certain amount of CPU, right? Computer instructions to execute that. And that factors into performance, into the latency as well. And again, adding more CPUs doesn't just linearly scale to address performance. And with an in-memory OLTP solution, you can have what is a natively compiled stored procedure. And these are optimized and compiled into machine language when they're created, which gives us a much shorter execution code path, which means that it reduces the number of computer instructions. So we reduce latency overall. And the original proposal for the engine to support in-memory was introduced in 2008. And they started the planning in 2012. It didn't get implemented until 2014. So it wasn't a quick fix, right? Nothing that came into play quickly. There was definitely a lot of work behind the scenes to make this feature viable. And the original goal that Microsoft had was to execute OLTP transactions in microseconds, so less than a millisecond, which is what we very often talk about in terms of latency and query duration, but microseconds. And they can do this because with the in-memory OLTP, they have optimistic concurrency, and there's no locking, no latching. In addition to the fact that the data resides in memory, it doesn't have to ever be read from disk into memory. It's always in memory. And the way that those data structures exist in memory, very different than the on-disk data structures. And they don't have the locking and latching. And log records are still in play here, unless you are non-durable, which we'll talk about. And those log records get written when the transaction commits, or if you're doing delayed durability, which is again 2014 and higher, at a set time. Microsoft talks about the fact that you can get up to 30 times improvement in performance. And again, this is not a knock on Microsoft, but there are very specific solutions that are discussed or shown when Microsoft talks about this. And your mileage is going to vary. And that's the most important thing that you can take away from this session. It's going to depend upon your workload. It's going to depend upon your access patterns. And something like maybe a 10 times improvement is more realistic. So I don't want you thinking that this is the end all be all. That's what we're going to do. And one other thing that I want to note here. I talked about, I'm going to go back a couple slides actually really quick. When I talk about hardware sometimes isn't an awful thing, right? Sometimes we think I'm going to throw hardware at the solution. But sometimes the right hardware, the right storage might be a better solution than the in-memory. And with some of the hardware that's available today, with some of the storage that's available today, you could possibly get the same level of improvement with performance that you may see with in-memory, because some of that storage is really, really fast. Glenn Berry, who's one of my teammates, he's our hardware guru. And you can get latency numbers. So when we talk about our in-memory and when we talk about the different objects that exist, there's a few that I want to hit here. So we've got tables, we've got table types, we've got indexes, we've got a file group, and then we also have these natively compiled T-SQL modules. So let's roll through these here. So our memory optimized tables are going to store user data. So just like we would normally put data into a clustered index or a heap, and we'd have non-clustered indexes, we have a memory optimized table to store that information. And by default, that data is durable, which means that it's going to persist across a restart. So even though we're saying it's in memory, it is going to stay within the database if there's a failover, if there's a restart. And how this works is if you imagine you've got memory, and you imagine that you've got your disk, right? Your database out on disk, and you've got your transaction log out there. You've got some data that you write into this memory optimized table. And in the scenario where you've got a durable table, that data has to get, the information about that data has to get written to disk. And so that will occur. And so when that transaction commits, there's information that gets written out to disk so that that will persist through a restart. Now you can also configure the memory optimized table to be delayed durable or non-durable. So delayed durable is going to look like some data gets written here into memory. And then in that scenario, there's a wait, right? There's a delay. And eventually it gets written out to disk, just like in the durable scenario, right? But there's a delay between when that data gets inserted and when it actually gets written out. Different than non-durable, right? In our non-durable scenario, we've got our memory and disk again, and we have some data that gets pushed into our non-durable table. And in that scenario, this is it, right? There is no scenario where that gets persisted. So in the event of a failover here, that data gets lost. So non-durable means we take disk entirely out of the equation. Nothing has to be written to the transaction log. But if the system goes down, we lose everything. So non-durable is ideal for data that's transient, data that can be repopulated, something like a session state database. Understand that with these tables that are memory optimized, not every single data type is supported. So there are some limitations there. Now, this is fun. PowerPoint has stopped working. So I think in 1 second, PowerPoint's going to go away. There it went. It's going to restart. Thank you very much. Hold on 1 second. Let me get back to where I was. There we go. So besides tables, we have table types. So these are memory optimized table types that you can use to replace temp tables, table value parameters, table variables. And this is going to hold transient data, right? So your temp tables, your TVPs, your table variables, that's holding data temporarily. The table type is designed to replace that for that transient data. And the benefit here is that we're only storing information in memory. There's nothing that has to be backed by tempdb. So when you use a temp table, you create that temp table and it's in memory, but there has to be pages on disk to back that data in the event that it has to be flushed to disk. So there's still, even though the temp table, the table value parameter, the table variable is in memory, there's still access to disk. There's still allocations that have to occur. With a table type, that is not the case. There is nothing that happens in tempdb. Everything is in memory. And if you use a table type, you've got to have at least one index here. So what this looks like in terms of code, the top code here is what we would use to create a table variable, right? So we would create the @order info, define it as a table, define our columns here, and then we would use that in our code. Versus creating something as a table type, it gets created as a type first, right? Create type and whatever we want to call it as a table. Notice that for the order ID, we've got a non-clustered index there. And at the end, you see that we have with memory optimized equal on. and to use this then in code, right? This gets declared within our database, gets defined. Declared isn't the accurate word there. Defined, that type does within our database. And then in our code, we declare the at order info and we reference that table type that we created. So that just replaces what we would have used before with a table variable or with a temp table. Now, I mentioned indexes, and these indexes are not quite the same as what we see for disk-based table. Every memory optimized table has to have at least one memory optimized index. Through 2016, there was a maximum of 8. There's no limit in 2017 and in Azure SQL Database. Remember the words of wisdom from Kimberly Tripp, just because you can doesn't mean you should, right? We should still be thoughtful in how we index. But when we talk about indexes for in-memory objects, we talk about non-clustered and we talk about hash. And there's some really good documentation in Microsoft documents that goes into detail about the differences between these two. The non-clustered is going to support any kind of a range scan, any kind of an inequality if you need a sort. The hash is really ideal for equality predicates, right? Where something equals a value with those key columns for that hash index. And when you've got a hash index, one of the tricky things about it is you have to estimate how many distinct values you have. So if you know that you're going to have 10 million rows in a table, then the question is, okay, when you create a hash index, let's say on order ID, do you have all 10 million order IDs unique? Probably so. But what if you created a hash index based on a status, right? How many unique statuses will you have? So hash index is it's a new way to something different that you have to think about compared to when you create a non-clustered index. And the indexes, this is kind of cool here, they're not actually represented on disk in any way. If you have to fail over or restart, those get rehydrated from the table data when the system comes back online. So that's something to think about in terms of recovery time objective, right? Your RTO, because for that database to come online, those indexes had to get rebuilt or recreated. And if you've got 32 gigs, 64 gigs, 100 gigs of indexes, that's a lot that has to occur as part of a failover or a restart. And those indexes don't fragment the same way that disk-based indexes do. Now, the file group is used to support these structures, and this is something that's really interesting. You have to create a separate file group that's defined as memory optimized data, and you only get one file group of this type. Now, you can create many containers in there. I tend to think of a container like a data file, but it's interesting because it doesn't really have a file extension. It's not an MDF or an NDF file. So they'll look like files, but kind of not. And you can create more than one. You can put those on different drives if you need more space. You can add more if needed. But you've got to have enough space to support 4 times each of your memory optimized table that's durable. That's not insignificant, right? If we're looking at standard edition and looking at having something that maybe supports 32 gigs, right, of space, then we've got to have 4 times that, right? 128 gigs of space on disk to support that. So an important consideration to think about there. Those file groups have checkpoint files that track the changes to those durable objects. And that's how the indexes, that's how the tables get rehydrated after a restart occurs. And want to make sure that instant file initialization IFI is enabled. I'm sure that's something you double check anyway in your environments, but particularly here when you're using in-memory. And then we have, separate from those structures, that natively compiled T-SQL that I mentioned earlier, which is really there to optimize CPU, to reduce the number of CPU instructions that have to occur. So when you create these natively compiled T-SQL modules, stored procedures is what we tend to think of for the most part, but you can do triggers and you can do scalar UDFs. Those get optimized and compiled into machine language. So that removes compilation CPU time, right? That occurs the very first time that compilation occurs, and that's it. And then stats in 2014 aren't automatically updated. You have to initiate that manually, but it does occur automatically in 2016, as long as you have compat mode set to 130. Something to note, though, is that updating stats doesn't initiate a recompilation like what we see with traditional stored procedures. So difference in functionality and how the stored procedures work here compared to what we're probably used to. So that's a little bit of background in terms of the basics surrounding in-memory OLTP. Now, is that then the right choice? Is that what we want to implement? So first of all, you've got to think about, well, what version am I running? I got to be running 2014 or higher. If I'm in 2014, I have to be an Enterprise Edition. If I'm in 2016, I have to be an Enterprise Edition unless I'm running Service Pack 1 or higher. And I have a limitation then of 32 gigs. Same for 2017 in terms of Standard Edition. So first, what version am I running? Can I do this? Then I need to start thinking along the lines that it's not a solution for every single performance problem that's out there. If we're talking about problems related to execution and accessing data, that can help. But if we're talking about client connectivity issues, or if we're talking about issues related to writing to the transaction log, you may not see a performance benefit there unless you are implementing something as non-durable. Because even though it's in memory, the transaction log is still in play here. So you still need to think about storage, and you need to look at the performance of that drive. Ideally, when we're talking about in memory, we're looking at small transactions. Large volume is fine, but small transactions, right? It's OLTP. It is not reporting. It is not data warehouse. It's OLTP, short, fast transactions. And we're looking here to help with solutions that have a lot of transactions so that we can increase the throughput, increase the frequency of those. We want to have data come in faster than as a result of that, right? If we can execute more transactions, then we can have more data come in. And we want to decrease overall latency for the time of those transactions because our application, our business is really sensitive to that latency, right? There's a lot of companies out there, like in the financial industry, that have SLA, service level agreements for how long a transaction can take. It has to take less than 100 milliseconds. It has to take less than 20 milliseconds, right? So if you have an SLA and you have to meet that, maybe an in-memory OLTP solution is for you. It's also very good for transient data, temporary data that doesn't have to persist or that I can recreate if needed. So where does it work well? Well, if I've got inserts, updates, or deletes, right? I'm pushing in a lot of data, loading a lot of data. If I'm doing updates, if I'm doing deletes. But I'll tell you that I've seen inserts in my scenario perform the best. And once I have that data in there, the inserts way outperform the updates and deletes. And then once I have that data in there, right, reading that data that is pretty much read only or not really being modified, that occurs very quickly, right? That's a good solution or a good option for where we could put OLTP in memory OLTP in there. It can work in terms of replacing your temp tables, your table variables, your table value parameters. And that's one of the easiest places to start. That's one of the, I would say, I don't want to say low-hanging fruit because it's not just an easy implementation. There's a lot of code change that goes in there. But that kind of is like a little gateway, in my opinion, for testing out OLTP. Staging during ETL, in-memory OLTP is a great option for that because, again, if there's a problem as part of that ETL, you can typically reload that data. I've got a customer that uses this as part of their initial data load. They're pushing the data into in-memory OLTP objects, and then in the background, they have something else that's running that's taking the data from there and moving it to disk-based tables, right? But they need to get that information in as quickly as possible, and then threads are running in the background to offload that to their disk-based tables. I had mentioned the session state database previously. If you're using that, that can definitely go into in-memory OLTP. And if you're doing any caching, that's an option for you as well, because again, that data does not have to persist. So where doesn't it work well, right? Where might it not be an option for you? Well, if you don't have enough memory to support those tables, that's going to be a problem. So one of the first things you need to start looking at after you think about, okay, what version, what edition am I running? The next one is, okay, what am I thinking about putting into memory, and how big are those objects? Because that's going to help me figure out how much memory I'm going to need. Then we have to look at the transaction log. How's my latency look on that drive where the transaction log exists? Because if I can't do anything about that, and that's a bottleneck for me now, going to in-memory in OLTP isn't necessarily going to fix that. And it's OLTP. Again, I'm going to hammer that point home. So if we're looking at returning lots and lots of data, or we're performing aggregations, this is not the solution for you. If you're looking to do scans, table scans, or range scans, this is not the solution for you. If you've got plans that are using parallelism, this is not the solution for you if you want to use those natively compiled stored procedures, because those don't go parallel. So if you've got latency due to something outside of SQL Server, like the transaction log, like a chatty application, you may not see a benefit from in-memory OLTP. So it's important to look at the problem that you're having and understand what problem you're trying to solve to determine if this is the right solution for you. And I'm huge on testing. And that's really one of the things I'm going to recommend here. If you ask me, if you put in the chat window, I have this, this, and this, should I do this? I'm going to say, I don't know. You're going to have to test, right? And that's what I've told several of my customers. This is what we have to try. And we need to look at the data to see if it makes sense for us to do. So how do we go about that? How do we go about implementing and testing in-memory OLTP? Well, now it's time to take a look at a little bit of a demo, because I've been talking for quite a while, and not having a demo sooner is extremely rare for me if you've watched one of my presentations before. So I'll try to take my time going through this code. I have a lot going on in terms of this demo, because I want to show you some differences in disk-based versus in-memory with regular stored procedures versus in-memory with natively compiled stored procedures. So we're going to make sure that I don't have this database in place already. And then I'm going to go ahead and create my in-memory testing database. And we're going to, as you can see, add a file group that's for our disk-based tables. And then I'm going to add a file group that is for memory optimized data. And I'm going to create a container on there. And you'll notice that it's just named in-mem OLTP F1, and there's no file extension on here. So we'll go ahead and create that out on disk, and then set that to full recovery, and then we'll change it so that we're using that database. And we're going to create 3 sets of objects that are very similar. So first is our disk table, and we're going to have the same columns in each of these. And what exactly those columns are not important. What is important is to understand that I'm creating these tables with all of the same structure. So we'll create this first, and then our procedure is basically going to loop through a number of times, however many times that I want, and insert into our table 1 row at a time. So I'm doing individual inserts here. And we're basically just saying, how many of those do I want to do? What's my num rows for that? And so we're going to do each of these about 10,000 times. So we'll run that. Now we're going to create an in-memory table that looks exactly like our disk-based table, other than we've got memory optimized on, and you'll see that we do have this as durable. So we'll go ahead and create that. And then I'm going to create what I would call a traditional stored procedure. So just like our other one. So this is not natively compiled. This is a regular stored procedure that is inserting into that in-memory table. So the first scenario, we have a disk-based table and a stored procedure that inserts into that. The second scenario, we have an in-memory table and a stored procedure that inserts. The third table is also going to be in memory. So it looks just like the one I just created. But now I'm going to have a stored procedure that has native compilation here. So this is going to then get compiled, and this is going to really, this is really what's going to be the performance difference here. So it's going to be the same thing. It'll execute a certain number of times, and it will insert into that in-memory table. Now, I want to track data. I want to track performance. One way I can do that is one of my favorite tools out there, Query Store. So we're going to enable Query Store for this database. And in order to capture metrics about a stored procedure that is natively compiled, you have to execute it first and then enable performance stats collection, because there's overhead that comes with this. So by default, it's not enabled. So we're going to go ahead and execute that stored procedure. And then we're going to use this stored procedure to enable the collection of query statistics. And there's a couple different ways you could do this. There's XTP control proc exec stats, and there's XTP control query exec stats. One does it just for instance level, one does it, and it can either be instance level or query level. So we'll just run both of them. And then if I want to confirm the state of the collection flag, we should see that collection is set to 1. And then I'm going to get rid of that data that I just put into Query Store so that we're starting completely fresh. So that's our setup. Now, we're going to create a database that tracks performance metrics. This is a test harness, and I would recommend this, or you may have other methods, but this is an option for how you could go through and do your testing and collect data. I'm a big fan of data, right? Because then you can take that data and say, look, this definitely provides a benefit. Or you can say, look, this definitely is not going to help us here. So I'm going to create a test tracking database that's just a regular traditional database with no in-memory objects. And we're going to track some file stats. We're going to track some weight stats, and we're going to track some, which I actually would probably track perfmon using perfmon, not using DMOS performance counters DMV. But I was being lazy here, to be really honest. So here's my test harness. I have 3 scripts, one for the disk-based tables, one for the in-memory table with the regular stored procedure, and one with the in-memory table with the natively compiled stored procedure. So what we do is we say, okay, how many rows are we going to insert? We're going to insert 10,000. It's going to insert into the test tracking database. It's going to drop any of my temp tables that I'm using, and then it does a snapshot. So it grabs file stats, it grabs weight stats, it grabs some perf counters. Then that's the start time, and it runs the inserts. Once the inserts are done, it sets my stop time. And then it snapshots my file stats and my wave stats and my perf counters, and it pushes that into the table. So there's a lot going on in here, right? This isn't 5 minutes and I'm off and testing. This is a fair bit of work here that occurred. So I'm just going to run this with an F5 and understand that we're inserting 10,000 rows. So this is, again, the disk-based table. So 10,000 rows took about 3 seconds if we look down here in the bottom right. If we look at the in-memory table with the regular stored procedure, and we run this one takes about 3 seconds, interestingly enough. So let's see what happens when we go in-memory natively compiled stored procedure. That takes a second or less. So now we want to look at our data. What do we see from the data? So if we just look at start and end times, right, we can see that the disk table insert of 10,000 rows and the in-memory table insert with a regular stored procedure takes about 3 seconds, right? Not a significant difference. So my point, what I want you to look at right there with those 2 numbers, and you can go and you can do this test with 100,000 rows, with 1,000,000 rows. The disk space starts to take a while when you really up that number, is that the in-memory object with a regular stored procedure here isn't giving me a ton of benefit. But when I do that in-memory object with the natively compiled stored procedure, I'm going from 3 seconds down to 1 second, right? Pretty significant difference here. If I want to look at my weight stats for each of those tests, right, you'll notice that here I've got write log weights for both of those first two. I don't have them in the last scenario. So there were some writes going on the transaction log, but there was no waiting that occurred as part of that. So I'm not seeing that here. I can look at file stats activity here. I've got that for test 1 and test 2. And then for my perf counters, this is why I probably wouldn't use perf counters here. I'd probably pull these with a regular perfmont, because trying to look at these is difficult. One of the things that you'll notice, one of the things that I want to look for here is what do I have in terms of my locks and my latches, because again, with in-memory, we are reducing that. But one of the things that is funny here is that I do get some access for locks, but I'm also accessing other objects within the time capture. So those locks are coming from the non-in-memory work that I'm doing. So I'd probably pull from perfmon again to make this data a little bit easier to review. And if I want to look specifically at query store to see what information I capture, what's interesting here is I didn't get the inserts for the in-memory. So what I'm going to do is I'm going to come back here and run this option and enabling. Let me just do this one here. Let me enable this all over again just to make sure. I had this happen when I ran through it once, and then I had it happen. Oh, wrong database. That would help, wouldn't it? Let's try that. Okay, so let me do this, and then I'm going to go back to my in-memory test. I'm going to run this again 10,000 times. And what do I get here? There we go. So here's my disk table inserts query. Here's my standard store procedure into an in-memory, and then here's in-memory with natively compiled stored procedures. So if we look at the number of executions, we had almost 10,000 executions here. And if we look at the average duration, this is in microseconds. So we've got 26, 27, and then we look at our in-memory with the natively compiled stored procedures, and it's down to 2. So my big point here is that you can put the objects in memory, but you really get the perf benefit if you can use natively compiled stored procedures as well. Let me see where I am with some questions here. I've been working, by the way, in terms of the audio on slowing down and also slowing down if I flip slides. So if there's still an issue, let me know. So let's see here. Let me look at this question. So where does the configuration for in-memory sit? Well, this is specific to the database. So this is the file group gets configured for the database. The tables, the indexes get configured for the database. So if you have a third-party vendor and a third-party database and you want to make these changes, those are not transparent necessarily to the application. So something like compression, right? You can go ahead and compress your tables. You can go ahead and partition, and that can be transparent to the application. But the in-memory, not necessarily the case. When I was talking about solutions where in-memory may not benefit, and someone asked about what is meant by a chatty application. It's an application where there's a lot of communication back and forth between the client and the database. So something that uses ODBC. ODBC is very chatty, so there's a lot of conversation back and forth there between the database. So is the difference in performance in the metrics that we're looking at here? Right? The big kicker here, the big take home is that in these two, in this first scenario, this bottom one, right? Look, disk table inserts. So we're just using a regular stored procedure and we're inserting into a disk-based table. Average duration for each insert, 27 microseconds. Here, I have the table in memory. I have a regular stored procedure and the average duration there, 26 microseconds. In this scenario, we have the object in memory and we have a natively compiled stored procedure and my average duration is 2.7 microseconds. And that difference is the fact that it's a natively compiled stored procedure. So we've reduced the number of computer instructions that have to occur. Okay. And then in this scenario where we have a natively compiled stored procedure, can there be a parameter sensitivity issue? Sure, because it gets compiled with specific parameters, and those are the ones that get used over and over again. So good question. Definitely still an issue to consider. And you need to understand then your data distribution to see if that's potentially going to be a problem for you. So it is not a silver bullet, right? All right. And I'm not, I want you to understand, let me be very clear. I'm not knocking in-memory OLTP. I think that there are some definite solutions. You have to be able to test and understand where it works for you and where it doesn't. That's my whole point today. So I want to show something else. That is the option of replacing the use of tempdb. So we're going to create another database here. And I know there are some more questions out there. I'm not ignoring you. I'm just wanting to make sure that I get through this demo and then I can take questions after the fact, because I know that sometimes people have a meeting at 1 o'clock or whatever time it is in your time zone in 15 minutes that you got to get to. Sorry, I'll slow down. So here I'm going to create my database. I'm going to create my file group again, put a couple containers in there, or put a container in there, which is a file. We've got that database created. Now I'm going to take a stored procedure that uses a traditional temp table, right? So we're going to create the stored procedure. We're going to create a temp table, and then we're going to insert 100 rows into it. And when we do this, right, and typically, then the temp table just goes away when we're done with it, right? We can specifically issue a drop, or when that session disconnects, that temp table is gone. So there's a traditional one. Now we're going to create an in-memory table. And this, by the way, is to show you that this is not how I would recommend doing it. So my traditional temp table use here. Then we're going to go ahead and create a table that looks just like our temp table. It's got a couple more characters, but, or excuse me, a couple more columns. So it has the first two the same, but then you'll notice that we have this session ID filter. Because if I create this as a table to replace using a temp table, I'm not just going to drop this in my code. I'm not going to create this table in code, insert into it, and then drop it. I'm going to create it and use it. But in order to use it, once I insert rows into it, it's not going to just disappear when the session disconnects, and I'm not going to drop it. So I have to clean up after myself, and I have to clean up based on my session ID. So we'll create this table. And then I'm going to create my in-memory natively compiled store procedure, which does the exact same thing as before. It inserts into that table. And after it does its 100 inserts, then because I'm done with whatever I needed to do, I have to delete that data out of there. So let me run that. And then again, I'm going to use my friend query store to capture information. I will execute that stored procedure one time, be nice to tempdb, and make sure that I have query execution stats enabled, so I'm capturing that. And then I have some external scripts that I'm going to run. So here, we'll go into this. So I have 10 clients first. Basically, I'm just running that stored procedure 10 times. It already went away to do those 100 inserts. And the second one just runs that to do this with in-memory with that natively compiled stored procedure. And it just does 100 inserts as well. So we're going to let that roll. Maybe. Gives me a chance to drink some coffee and to take a look at the questions. Ooh, one good one I just got. Why not truncate the in-memory table? You know what? You cannot truncate an in-memory table. Yes, you heard that right. You can't truncate an in-memory table. So let's see what we get in terms of performance. So in my abused tempdb, which used the temp table, right? This did an insert into the temp table. We ran 1 million of those. Average duration was 13 microseconds. When we did our in-memory table that we also had to delete from after we inserted, right? Because we have to clean up after ourselves here because I can't truncate and because I'm not going to create it and then drop it and then create it and drop it. So for these second two, we did 1 million inserts, which took 0.4 microseconds. This is the kind of performance that you're told you're going to see, and which we absolutely do see. But notice that for each of those that we ran, we had to do a delete, which took longer. So our total duration here would have been what, 13 milliseconds? Oh, this is actually it, total duration in milliseconds. I did the math, right? Total duration in milliseconds here, 13 seconds. Here, this totals to just over a second. So it's still faster, right? Still significantly faster. But we have this delete to contend with. And there's a better way. This is why we talk about the table types. So in this case, numbers database, because I'm going to do something a little different, and I'm going to join to a table, but I want to show you how you would use the table type. Note, if you wanted to know how the performance differed here, I'm leaving this to as an exercise for you. You could go through and create the table type and then create the stored procedure natively compiled to insert into the table type and go through this exact same test and see what the metrics look like. That's one for you to play with. I'll give you the code for how to do this here. So I've already restored wide world importers. And in wide world importers, I am going to create a non-clustered index on the orders table that's going to support this query that I'm going to run. And I want to make sure that using my traditional temp table isn't here. So what we're going to do is we're going to create a temp table. We are going to insert into, whoops, don't start typing. That's just a bad idea, right? We're going to insert into that temp table. And then I am going to query that temp table and join to my order lines table, because this is something I see a lot in code, right? Where people push data into a temp table or a table variable, and then they join to that table multiple times, maybe join multiple tables together, and then they drop it when they're done. Okay, so this is a typical pattern that I see in code. So we'll go ahead and run this. And then we're going to create our in-memory table type. So I showed you this code in the slide, right? We're going to create the table type of order info. It looks just like our temp table, other than it's a table type memory optimized. Create that. Now I'm going to create a stored procedure that looks just like our other one. And this is still a regular stored procedure. This is not a natively compiled stored procedure, because this stored procedure joins to a disk-based table. And a natively compiled stored procedure, this is important, a natively compiled stored procedure can access in-memory objects. It cannot access disk-based objects. So we're going to create this same procedure that we saw before, and we will insert into that table, and then we will join to our table type and to the order table as well. So we're going to create this. And then again, my best friend and yours query store. We will enable that. Can't say enough good things about that feature. And I'm going to clear it out because this is a demo database that I've restored, so who knows what was in there. Don't run that in your production environment unless you want to remove all of your data, which would be a bad thing. And here's my table variable. So first we're going to use 10
Erin, with the screen moving, we're not hearing anything you're saying. Or at least I'm not. Erin, no audio at all.
Okay, am I back? Can you
Yes,
hear
you're
me
back
again?
now.
Yes, so I
I can hear you now.
apologize. Yep, so what happens there is that code causes my CPU to spike. And when the CPU spikes, I'm losing my audio because I live kind of out in the country, I admit it. and my internet is not as fabulous as some of yours. So forgive me. Let me run this one. If I lose you, I'll be right back. This one should not take as long. This is all the in-memory. Okay, can you hear me again?
Yes.
Yep.
Perfect. I apologize for that delay. I wanted to let that code run. Thanks for your patience. So now we've run those scripts. And again, we had a traditional temp table and we used a in-memory optimized table type, but the stored procedures were both the same. Neither one of those were in-memory stored, in-memory natively compiled. So if we look at the data here, what we see, let me run this again. Let me see if I can get this to flush. Okay, so we have our abused tempdb, which is our traditional temp table, and we have our let's be nice to tempd, which is the table type. So if we look at our duration data here, it's pretty close in scenario. And if we look at what we have in terms of IO, because that still has to occur because one of those tables is disk-based, we still have that as well. And if we look at our CPU, there's nothing crazy or impressive there. So let me run this one more time and let me see if I can get this to aggregate. I need the data to flush. This is just a behavior within query store, which is not a particular problem per se, but I'd like to see this data aggregated. But here in this scenario, right, using that table type, again, doesn't give us a ton of benefit. And part of this is because we don't have the in-memory natively compiled stored procedure in place here. And I am not showing you this demo to dissuade you from using in-memory. I want you to really critically think about how you would use it because it's a big effort. And I'm going to switch back to the slides to roll through a couple more points, and then I'll answer any questions that we have at that point. So I've shown you how it can be really great and really help performance. And I've also shown you scenarios where it doesn't necessarily give you huge benefit. And to be clear, it's not a ding on Microsoft. It's not, I'm not telling you that the feature doesn't work. I'm telling you that there are specific use cases for the feature. You have to think about that. So requirements, right? Must-haves, cannot get arounds. You've got to have a separate file group in the database. And oh, by the way, when you create that, you can't go back and remove it down the road. So if you create the file group and you think you're going to do in-memory in production, and then you decide later on you're not, you don't get to remove that file group. That might be a deal breaker. And you can't create database snapshots if you've got this file group. You need to have enough memory to hold those tables and indexes. And that's something that you're going to have to work with to figure out exactly what that is in terms of how much memory you need. The table is going to be about the same size as if it were disk-based. Indexes are typically a little bit smaller. You're going to need additional memory to support the workload because there's also row versioning that goes on in here. And you need to make sure that you have disk space to support this. So you're going to be consuming more memory and more disk than you have been traditionally with the disk-based objects. And the natively compiled stored procedures are optional, but as you've seen, highly recommended to really see significant performance gains. Now you've got some limitations here. Not every feature is supported: compression, partitioning, replication, linked servers, DDL, cross-database transactions, right? That's a deal breaker in some scenarios. Not all data types are supported. I had a customer that really wanted to use this for their geography data, and they weren't able to put everything in memory. They were able to put a few things, but because that geography data type isn't supported, they couldn't use it. Computed columns are supported in SQL Server 2017, but not before. You can use an identity, but it has to start at 1 and seed by 1. And you can't reseed. As I mentioned earlier, you cannot use truncate table. And migrating a table that you have to in-memory is an offline process. You can't just do an alter table. And CheckDB cannot validate those in-memory tables. That's also a deal breaker for some folks. When you run CheckDB, you can run it, but it will not do any checking of those in-memory objects. So you can still run CheckDB against a database that has in-memory data, but it will not check that in-memory data. So some notes about the natively compiled stored procedures. You can only access the memory optimized tables and table types. You can't access a disk-based table. Those stored procedures don't have parallel processing. They are typically compiled using unknown values, although you can use an optimize for, but if you've got parameter sensitive data, as someone asked about earlier, that may not be ideal. The query plans use nested loop joins, and there's only stream aggregation for aggregate. So again, OLTP, right? Not running in parallel, not aggregating large amounts of data. And those execution stats aren't collected by default because of the performance impact. You have to enable that specifically. You can't create or access data with IntempDB. You need to either use memory optimized table types or the table types table variables. There's some other limitations that are listed here. I'm not going to read through every one of those. These are well documented, but be aware, right? Things that you may be doing in code are not things that may be supported in a natively compiled store procedure. So now that I've told you what you can do and how to test for it, how do you determine if it's really going to be viable in addition to the testing, right? There's a couple things built into SQL Server that can help you. There's a transaction performance analysis report for your database. So if you right click on the database, you go into reports, you can see this transaction performance analysis. And it's going to look at that workload to determine where it might provide performance improvement. So if you don't know if your workload would benefit, this is a good place to start because it's capturing table and stored procedure metrics to give you that information. And it will also tell you if there's something incompatible or something that's not supported. For specific tables, there's a memory optimization advisor, which will tell you if that table can be migrated. And if there are limiting factors, it's obviously not going to do anything, but it's something that you could use to migrate, or you could generate the script to do so. I'm a huge fan of generating the script. UIs are really nice, but I would rather script that out and I would rather control that process myself, because if I have that script, I can put that into source control, change control, all that good stuff. You've also got the native compilation advisor to determine if a stored procedure can be migrated. It won't migrate it via the UI itself, which again, totally fine, but it will tell you if there is a problem and there's something that won't allow you to go to native compilation. If you're going to give this a shot and see if it makes sense for you, you are going to have to create a baseline. You could use Query Store. If you're on 2016 and higher, you can create this manually. You could do this with a third-party tool. The metrics that you care about are the ones that you have to capture, and I've got a slide that lists a few of them. When you're looking at this performance change, you really want to isolate this. I don't want anything else to be different. I'm not going to try to have different data sets in there. I'm not going to run any kind of a maintenance. I'm not going to change my index structure, right? I'm really trying to do an apples to apples comparison where only the objects are going into memory. So I would do this in a non-production environment, and if you don't have one, then I wouldn't do this, right? Because this requires an outage. It requires an outage in order to make the change. It requires an outage in order to roll back the change. You still have your typical testing challenges, right? How do I create the right workload? Am I going to be able to test all of my code? So start simple. Start with a table or a small set of tables that are related and work through those. You're going to look at capturing those performance metrics in production. You're going to take that database, you're going to back it up, you're going to restore it in the test environment, you're going to make whatever changes you need to put whatever objects in memory, and then you're going to run through ideally that same production workload and capture those metrics again. And then you're going to compare, right, and decide if it's worth it. And ideally, you're going through as much of your code as possible. Things that you want to look at: CPU, memory, disk, locking, latching, wait stats, transaction duration, query duration, batch requests per second, right? You should expect to see a boost in the number of queries you can execute per second with something like in-memory OLTP. And then there are specific counters for in-memory, those XTP counters. So if I haven't scared you away entirely, here's some additional resources that I would recommend reviewing as you get started, as you dig into this. And that's kind of our review. That's what we went through today. And let me see what I've got for questions. I have a few. I know we're 5 minutes over. I apologize for any of you. If you've got to be somewhere else, can you do this with an availability group? Yes. File groups, you can't remove them. Can you shrink the files contained within them? You know, that's a great question, Eddie. I believe so, but I haven't verified that. Can you have a primary foreign key on memory optimized? Yes, that was added, I think, in 2016. And let's see. If I have a durable table, we will have write log. Yes. Even if you have natively compiled procedures. Yes. So that was one of my big points. If the transaction log is one of your holdups or issues, even if you go to in-memory and you're durable, you're still going to have to write things to the transaction log. Let's see. Yes, the slides will be shared. Yes, the scripts will be shared. Check the DBA Fundamentals website for details. Give me a couple days to get them over to the team. And I'm 6 minutes over. I don't want to hold you up any further. If you have additional questions that I didn't get to that I'm missing here in this list, I had lots of questions. So thank you guys very much. You were awesome and you had a lot of great things to ask. Please feel free to send me an email. I'm happy to address them offline. And if there's enough, maybe even I'll write up a blog post. So guys, I'll stop now.
Thank you, Erin. That's okay. We'll send you a copy of all the questions so you can look at them if you want to. If you see
Perfect.
something you say, hey, I'm going to blog about this. So anyway, I appreciate it. We've got a session next week with Glenn Berry down under talking about migrating to 2017. And then we've got a session back with Glenn Berry. It just so happened that it worked out that way with our Australian contingent. So anyway, have a good rest of the day. Thank you.
Thanks all.